Okay, so this video is called Introduction to Logic, and we're going to start out with a definition of logic. Our definition of logic is the principles of correct reasoning. Now, there are two basic types of reasoning. One is called inductive reasoning, one is called deductive reasoning. Inductive reasoning is used to identify patterns and to make educated guesses about these patterns. Now, educated guesses, when we talk about educated guesses, we're going to use this word conjecture. So conjecture is just a fancy word for educated guess. All right, so anytime you're involved in making guesses about patterns, you're engaging in inductive reasoning. Deductive reasoning, on the other hand, uses logical arguments to prove that conjectures are true or false. Now, let's take a closer look at inductive and deductive reasoning. Here's an example involving inductive reasoning. Every Friday so far this school year, the cafeteria has had chocolate chip cookies for dessert. What kind of dessert would you guess the cafeteria is going to have this Friday? Well, based on our experience so far, every Friday the cafeteria's had chocolate chip cookies. That's a pattern that we recognize. It would make sense to guess that the cafeteria is probably going to have chocolate chip cookies again this Friday. So our inductive reasoning in this case leads us to make an educated guess. It leads us to conjecture that we're probably going to have chocolate chip cookies this Friday in the cafeteria. Now, notice this isn't foolproof. There's no guarantee that we're going to have chocolate chip cookies this Friday in the cafeteria. The truck that delivers the chocolate chip cookies might break down, or somebody might change their mind and just decide to have peanut butter cookies this Friday. But, you know, again, based on our experience, based on this pattern that we have noticed, we think there's probably a pretty good bet that we're going to have chocolate chip cookies this Friday. That's inductive reasoning. Deductive reasoning. With deductive reasoning, we start with given facts and we use logical arguments to arrive at a conclusion. So let's take a look at a couple of examples of deductive reasoning. Example number 2. Given. When it rains, Kelly always carries an umbrella. If it's raining now, what could we deduce about Kelly? Well, we have some given facts here. The given facts are when it rains, Kelly always carries an umbrella. And we're going to use a logical argument to say, well, if it's a fact that when it rains, Kelly always carries an umbrella, if it's raining now, we can say Kelly is carrying an umbrella. All right, let's take a look at another example. Given, Ray is an American and all Americans are human. What can we deduce about Ray? Well, the given facts are that Ray is an American and all Americans are human. From that, we can deduce that Ray is human. We've taken our given facts, we've used logical arguments to arrive at this conclusion. All right. Now, notice this is different from inductive reasoning. We're not recognizing patterns here and making guesses about them. We're actually taking facts and we're using those facts to reason to a conclusion that we can prove. We can state with complete conviction that Ray is in fact human. That's deductive reasoning. Now I want to talk a minute about something that I call the deductive chain of reasoning. Take a look at this, this example that we just did. We could state this another way. We could say our given is Ray is American and Americans are human. Well, we could restate that in kind of a math-looking way. Ray equals American. Ray is an American. And American equals human. That is, Americans are all humans. And we could restate this in yet another way. We could kind of shorten this a little bit more. Ray equals American equals human. And notice we can kind of think about this as a chain. We've got these three links in the chain. Ray is equal to American is equal to human. And that allows us to kind of draw a conclusion or make our links in the chain go from Ray to American to human. So anytime we can make those links in a chain, we're using deductive reasoning. And once we've finished constructing our chain, then we can say that we started here and we got here. And that's kind of the basic outline of what is called a proof. And we're going to get into proofs a little bit later. But proofs use this basic approach. You make a chain of logical arguments, and that chain becomes your proof. So we've essentially proved Ray must be human. Now let's take a look at a few more examples. Example number 4. Given, when the sun shines, the grass always grows, and when the grass grows, it always needs to be cut. If the sun is shining, what can we deduce about the grass? Well, since when the sun shines, the grass always grows, and when the grass grows, it always needs to be cut, if the sun is shining, we can deduce the grass needs to be cut. Let's take a look at example number 5. Given, all dogs are mammals and all mammals are vertebrates. If Shaggy is a dog, what can we deduce about Shaggy? Well, since all dogs are mammals and all mammals are vertebrates, if Shaggy is a dog, then Shaggy must be a vertebrate. And we've constructed another chain of reasoning. Shaggy is a dog, all dogs are vertebrates, therefore Shaggy must be a vertebrate. Example number 6. Given, every time Frank eats tomatoes, he feels nauseous. Every time Frank feels nauseous, he throws up. If Frank just ate some tomatoes, what can we deduce about Frank? Well, it's not too hard to see that since we know, and we know this because it's given. What's given is we're accepting that as our given facts. Since it's given that every time Frank eats tomatoes, he feels nauseous, and every time he feels nauseous, he throws up, and he just ate some tomatoes, well, based on our given facts and our logical reasoning, our deductive reasoning, we can kind of construct a logical chain of reasoning. Frank just ate some tomatoes. Frank is going to throw up. Now, we have a couple of more examples in your notes. Examples number 7 and 8. Examples number 7 and 8 in your notes are pointing out faulty reasoning. And I want you to take a look at examples 7 and 8 and see if you can figure out what is it about the reasoning involved in those examples. What is it about that reasoning that is faulty? What's wrong with that reasoning?